So next, after talking about our waxes, a little bit more of a, I guess, complex version of a wax is going to be triacylglycerols, or so they're more commonly known as triglycerides. So these are when we have three fatty acids forming an ester with glycerol. So three esters are formed. So the general scheme that you'll see for something like this is over here, where you have glycerol vertically, and then you have your three fatty acids. So what glycerol actually looks like is this blue molecule here. So it's got three carbons, or three CH2s. Actually, it doesn't have three CH2s. It has three carbons. The middle one just has a CH. And it has our three carbons, and then it has on each carbon one alcohol. It's just called glycerol. What happens is you take your fatty acid, so I drew one here in red. You take your fatty acid and you'll do an esterification reaction. So remember, we combine, we form water, release water from this reaction, and we make an ester bond, an esterification reaction. So we'll do that 3 times. So I just drew one here, but then you can see here I have just saying do it again. So we form 3 new ester bonds. So in this one, we'll have glycerol plus 3 stearic acids. So now we have 3 new ester bonds, and this is our triglyceride, or triacylglycerol. I don't know how I did that. I'm sorry. Okay, so that's the general structure of triglycerides. And then how do we name these triglycerides? So the first word is going to be from glycerol, but we're going to change it to YL since it's at the beginning, so glyceryl. And then we're going to have the second part is going to be the name of our fatty acids, named as carboxylates. So for this particular example over here that we just did, this molecule that we drew would be glyceryl, and then because there's 3 of them, tristearate. So they are stearic acid to make it as their carboxylate name. You drop ic acid and add ate. So tristearate. So glycerol tristearate is the name of this particular molecule. Some properties of triglycerides. Most of them are mixed. So naturally occurring, most are mixed. So it's not going to be 3 of the same type of fatty acid. They're going to be at least 2 different types of fatty acids. So fats of these are typically solids at room temp, mostly from animals. And then oils are going to be liquid at room temp. These mostly come from plants. So really, in reality, these oils and fats have the same overall structure. It's just how long their chains are, really. So animal fats usually have more saturated fatty acids, so they end up having a higher melting point. Yeah, they're more solid-like. So the oils, so the liquids at room temp that are mostly from plants, have a lower melting point because they have more of your unsaturation in them. So they have more double bonds, more kinks in there to make space. And lastly, triglycerides are a major form of energy storage. So for our body, using up these fat molecules are really important for energy. But for another type of animal that it's really important for is hibernation. So for bears, for example, I really like bears. My undergrad mascot, we were the Bears, and I was super involved in sports and technically the spirit team at our university. And so I love bears, and we talk about hibernation all the time at my undergrad. But other than that side note, triglycerides are what's used up when animals hibernate. So this is these fats, or these triglycerides, are the only storage of any kind of energy for 4 to 7 months. Depending on the type of animal or whatever, or how long winter is. So that's why bears are everything. They try and get a lot of fat on their body, because while they're hibernating and asleep for those 4 to 7 months during the winter, their body, in order to keep the vital things running, uses these triglycerides as energy. Okay, that's where we're at. Good job, guys.